Okay. Hey everyone. We'll get started in 2 more minutes. Oh, and also, I don't know for those who are watching if you know about MIT time, but we usually start 5 minutes after the hour. So we're just going to be starting at 7:05 p.m. Eastern time. Okay, guys, let's get started. Hi, my name is Allison. I am a project manager at the MIT Assistive Technology Club. So it's a project team here at MIT. I'm a current sophomore in college. And yeah, we'll just get started. So basically, here are some pictures from our showcase last year in the spring. And I don't think I updated it with some of our showcase photos from the fall, but basically we are a project team. We have about 6 or 7 teams at a given time in a semester working on a multitude of projects. So as you can see here, we've got an iOS app, we've got a hand controller, and we've got a robotic grasping device. So these are just some examples in the past of what projects we've had. And I'll just be going over like what we do as a club more throughout this presentation and hopefully give you guys some ideas or some guidelines on like maybe how you can go about your project, this blueprint, um, this this weekend. So just as an agenda today, just gonna do a little bit more on the introductions. Oh, I guess I'm blocking a little bit, but also talking about what assistive technology really is, what we do as a club, and just some past and current projects we've done. Maybe it'll, as I said, it'll give you some ideas for what you can do during Blueprint. And we'll see if we have some time at the end for some Q&A. I'll be also looking at the live stream chat, and then also yeah, so we'll go ahead with that. Right now, I also have, so Eileen, I guess I'm blocking it right now. Eileen is not here right now. She'll be joining in a bit. But essentially, Eileen is one of the founders of MIT Assistive Technology. We're a younger project team club. She's also our previous president, so she's awesome. And she can probably introduce herself more later when she arrives. Uh, but yeah, my name is Allison, as I said before. I am a sophomore. I'm studying electrical engineering and computer science, and I'm a project manager on the team. So I help handle and make sure that all of our 6 to 7 teams are on track to complete their projects for the semester, providing them support for both I guess, ideating, for iteration, and getting them the resources that they need. I also, as a fun fact, was a blueprint organizer last year, so I'm really excited to give this talk and maybe help you guys come up with some ideas. Oh, okay. And also, I will be helping out with the hardware track. I'll be a mentor, so maybe I'll see some of you guys this weekend. So, what is assistive technology? So, according to WHO, assistive technology is just an umbrella term for like all the systems and services that can really help that can actually help people. So it's products, services, anything that can be there. I think I'm also still blocking it. But yeah, they basically help maintain and improve people's lives. It can allow people to actually act independently, and it really does help with people's well-being on a day-to-day basis. So it's a really important thing to think about. Just anytime you're working on a project or if you're working on an app, for example, you want to make sure that everyone can use it, no matter their ability. So some really common examples of assistive technology include, oh damn, I'm still blocking it. But yeah, some examples include screen readers. So that's text to speech. But you can also have speech to text. Sometimes that's actually a really good like assistive technology like tool that people use on a daily basis. Another one is eye gaze trackers. So let's say that you have a disability with your arms or your hands. It's a great way to actually control the technology that we use on a daily basis. Wheelchairs count as assistive technology as well. And as I go down this list, it sounds more and more like physical technology. And this also counts as assistive technology. So you got walkers and rollators. Rollators are a type of walker, a kind of like a another version. And then there's prosthetics as well. That falls under assistive technology. Um, But yeah, so basically a bunch of these products on a daily basis that you might see, and they all fall under this category, and they do a huge part in helping people on their day-to-day lives. So what do we do as a club? So we are focused on really creating these small teams that will develop assistive technology projects over the course of a semester, or even multiple semesters, as we've seen. So each team is paired up with a co-designer. There's no team that is just functioning by themselves. They're working directly with someone with a disability that they're getting to know, like as a person, and what their day-to-day lives look like, and they get to see like what are the things that maybe we can create or work with them to create a solution for a problem in their lives. So our club is like a kind of like a makers like project team environment where people can come and work on these really impactful projects. And we work with both hardware and software solutions. We can connect members to like different maker spaces and build teams. And there's a lot of resources at MIT. And we're a really hands-on community, so it's a really great place. Um, and then also at the end of the year, we just culminate with like these project showcases to show the community what we've been working on, um, especially because we want to open source some of our projects if we can, inspire others to also work on assistive technology, and in general, like educate people about like why this matters and why no matter what project you're working on, you should be keeping assistive technology in mind. Quickly check if there's any questions. Nope. Okay. So let's just go through like our mission again as a club. So we are an engineering program, so students can actually do some real hands-on engineering. It's a great way, like after classes, we get to work together on these projects. Um, Again, we meet and design with the direct users, the co-designers for each team. So for example, we might have a co-designer who has been blind their whole life, or maybe only blind for half their life. And how does that affect like how they interact with technology? You've got co-designers who are in wheelchairs who use rollators, and every single co-designer has like a different issue that they bring to the table and that they want to work with students to see if we can actually address these issues through a solution. So as it says here, we're designing for a specific person, not just an umbrella thing that could work for everyone, because we recognize that we want to make this as specialized as possible for a co-designer. It's also a collaborative process. We're not making like the solution for them. We want to make it with them. So a part of, I'll go into like the structure of the club later on, but Quite literally, we meet with the co-designers every single week. Like we have time for teams to meet with them, to work with them, to have discussions. Everyone's on the same like platform for like communication. So it's it's an iterative process and it's also very communicative. And yeah, we're building assistive technology and medical engineering and a medical engineering community. We really like to bring people together, reach out to maybe some professors who are interested, and basically anyone who's interested in learning more about assistive technology. Oops. Oh, and then also just some examples of projects. I think I mentioned this earlier. We do some software. So we've got like app development, web dev, etc. We also do a lot of hardware. So there was some electrical engineering ones. A team had actually developed their own PCB. And some mechanical ones, they're doing some structural analysis, looking at joints. So you can think prosthetics versus rollators versus wheelchairs. And then we even have some projects that combine the two. So we've got some robotics and systems projects that are ongoing right now. So this is kind of like what a typical timeline for the club looks like in one semester. It's a really fast process. Really, on our first day, we're going to hit the ground running. We have teams meet with their co-designers and teams starting to ideate. And by week 4 or 3, we're having teams present first of all, the problem they define, what that is, what a potential solution is, and some initial designs that they have. And then finally, we go through some design reviews. We're working together as a team throughout the week, but also during our like general body meetings where they get to meet with the co-designers. And then there's a final showcase where we actually get to show the community what we've been working on. So I just wanted to go through like our engineering process because it does pose as a really good framework. Even I guess in a weekend at Blueprint, you might be like, oh, I'm going to create a project for the hackathon. Well, you're going to have to go through some steps on like what the problem is and then how you're going to solve it and then eventually pitch it to the judges on what why it matters. Like what are you actually doing? Can you explain your process and can you explain your product at the end? So first of all, our process might be a little bit different because we do have co-designers. But I really encourage you guys to like think about this as well, maybe when you're creating your projects, like who are you going to impact in the end? So first of all, we always get to know the co-designer. We spend like the first week or two just talking. Like we've got ideating sessions, we're meeting them in person, and really communicating and getting and like trying to understand like what problems they face on a daily basis and maybe what we can do as students to what we can do with our engineering skills to address them. So kind of goes with ideating as well. We want to determine the specific problem and come up with the potential solutions and also narrow the scope. So for us, that means we want to narrow it out kind of in the span of like a semester. We want to make sure we can finish the project, first of all, and that it's still useful past our time. So trying to balance that is a little bit different than what you guys have to do. But I guess when you're at Blueprint, you also want to make sure you finish your project by the end of the hackathon. So uh, you're going to have to narrow the scope of your project as well. We always have like design reviews, and this way we can get feedback from other teams, from co-designers, from other students. And this is something that you guys can do too. There are mentors who are milling about. And there's all the Blueprint organizers around. I highly recommend you guys talk to the organizers and the mentors and get feedback on your projects because they might introduce something to you that you didn't think of, or they might be able to help you with an issue that you're facing. Yeah. And then design iteration, after you get the feedback and the constant feedback, you always want to actually start, I guess, making your product better or making your project better. Um, so we spend a lot of time as a club on design iteration and making sure that our solution is actually viable and usable by our co-designer. And then finally, there's always going to be documentation throughout this and a final presentation. And this is just important in terms of any project. You want people to understand where uh, your design choices were and like also even why you even took on this project. So context is important, the story is important, but also how you did it. And I guess for current teams, and previous teams that we've had as a club. These are just some of them. I'm not going to say all of them out loud because it's just all out there, but I'll be going through some teams that we've had in the past and that we have right now and why their projects are really cool. So here's an example of one that is actually still being currently worked on. This team has been around for a while. They're the blind assistance team. They're working with two co-designers now who are blind. And they have explained to us and about how like they interact with technology, how there's like screen readers and how there's like different technologies with iPhones. Um, but what they are working on specifically is trying to figure out like if they can make certain daily tasks like finding an Uber more accessible. If you need to find a specific object out there, use computer vision, and how you can make a phone essentially like a sensor for someone who is blind. Another team is the rollator modification team. So basically, they're working with a co-designer whose height specifications were different than most people. Like the rollators that are out there don't exactly help him like function on a daily basis because maybe he's too tall or there's some other thing that he wants like different about the technology that's out there. So that's what they were working on. They're working directly on issues that this co-designer posed as problems. And then finally, one-handed game control. This is a team that just wrapped up. Basically, this is the team I was talking about that they created their own PCB and really uh, designed and CAD'ed this final device where the co-designer, Susan, she could actually game and play Overcooked with just one hand. So this is kind of it. I think I went through this a lot faster than I thought, but I did want to spend time just like uh, if I can answer any questions that people have. I think
I'm here.
Eileen
I'm
has
here.
also joined. So I don't know if you want to also introduce yourself.
Yeah, my name's Eileen. I am a senior slash master's student now at MIT. I did my undergrad here as well, in ECS, so electrical engineering and computer science, and mechanical engineering. So I double majored, and am mostly focused on robotics, for research. But I started this club, in my sophomore year with a couple friends of mine, Max and Ben. And since then, I mean, it's taken off so much, and Allison's great. And it's only going to get better. So, yeah.
Let's see. I think I'll just say this last slide and then we can answer some more questions. I'm already seeing some questions in the chat, which is really cool, and I can read them out for you, Eileen, because I don't think I gave you
That's
the,
okay.
the live stream for this. But um I'll probably have to reshare the screen as well. But just some ideas or some thoughts that you guys should keep in mind throughout Blueprint. Just make sure that you really understand the problem that maybe you're trying to solve or that like what your project really is, who could be impacted. Sometimes that's a really cool thing that you could say in like your presentation to the judges. Um, and then also, we really, really love the hardware track. I am very much biased because mentored it last year as well. So really encourage you guys to explore how hardware could be integrated into your project as well. Um, and yeah, so let's do our Q&A then. Um, maybe I will try to attempt to figure out how to make this show both of us, Eileen, but I will give you the first question if you want.
Oh, okay. No, you can filter the questions. It's fine.
Okay, sure. Okay, so I got the question, are the co-designers also MIT students? And if not, how do you find these individuals to cater to?
Yeah, so it's a mix of students. We have three students right now who are MIT students. Last year we had one student who was an MIT student, and like six co-designers that weren't. So we originally tried to source from like the community around us, mostly in the Boston area. We want to have the co-designers be able to come in person, and really interact with the team, really be part of the co-designing process. And that we think that's best when they're able to come and be around with us. So we invite them to come to MIT every week, and they work with students and they design with students. But it is obviously very easy to also get students at MIT and then be able to work with them like all the time. So we're trying that out now. Yep.
Okay, cool. Someone asked, is there robotics at MIT? In high school, we have Vex Robotics and First Robotics. So what do we have here?
Yeah, there's a lot of robotics in kind of every facet of it. Depends on whether you like computer science or if you like mechanical engineering. I know that for if you did FTC, FRC, like I did, Woody Flowers is a professor here, and some of the classes that in mechanical engineering are inspired by him or that he helped create. So, like famously, it's called 2007, and you build mini robots and you compete just like how an FTC robot, how FTC kind of works, except for now it's a class-wide competition. There's a bunch of other robotics classes here. Like there's upper level advanced classes like under actuator robotics and whatnot. And then there's a ton of robotics labs. So I work in the lab that designed the MIT Mini Cheetah, and now we're looking at the humanoid and manipulation platforms. So I work on learn controllers for that and trying to make it move without kind of you controlling it, without you holding like a controller in the hand, and be able to like interact with the world.
Awesome. No, yeah, Eileen is correct, guys.
Mm.
Anyways, but yeah, I can also kind of speak to this. There's so assistive technology is considered like an Edgerton like project team. So we're like one of many. I used to be on motorsports, which is also a team that's going to be talking tomorrow. So highly recommend checking that out as well. They're a really cool team. They build race cars. Um, but yeah, there's like a lot of resources for people who just want to build. There's like a group called Miters here as well, who they basically just build stuff. Really cool stuff. Like first impression of MIT, there was like a Tesla coil that they were playing a K-pop song on. So there's really cool stuff happening everywhere here, and the resources here are amazing. You can just build. Let's go on to the next question. Uh, since your group is the primary producer of these technologies, if the client needs help with the tech you made, who can they go to? What did the people who made it graduate?
That is a very good question. Should I take that or should you want to take that first?
Wait, you can take it.
Okay. Yeah, so that is like a really, really great question. Especially because we're such a young club. We've only been around for 2 years now. And kind of like it used to there used to be an AT hackathon where they did the same thing but over a weekend. And that was exactly the problem. The products were kind of hacked together really quick, and they were really great. They were amazing, and they were mostly grad students who were doing this. So they were really well formed projects, but they weren't necessarily maybe mature yet because it was only like 3 days. And so things could break down pretty quickly. And that was a complaint that we got from the people in the community that had participated with MIT before, and we're now kind of taking the leap of faith to work with us as well. So we're hoping that we're going to be able to open source all of our materials. We push for all the teams when they finish their projects to have entirely open source like code and CAD if that's the route they want to go with. Otherwise, if they want to turn it into a startup, that's also fine, but they're going to be continuing to work on it. And then in that case, kind of that would take a separate route. And then always to support the co-designer as they continue their journey. So we want to maintain a good relationship with the people in our community, and hopefully then we can kind of work together and expand our network.
Cool. Let's see. Okay, another question that we got is, how do you raise funding for your projects? I imagine the technology for them being difficult to find affordably. Really good question.
Do you want to take? Should I take?
Sure. Wait, I can take some of it. So we do get some funding from MIT itself because we are really supported by like the Edgerton Center, which is like a huge like education center here that supports all of these project teams. We go to other departments as well, but ultimately we also like are trying to find funding for projects that can get costly. We do have hardware projects as well. Um, but I think our idea, but that also kind of forces us to come up with really like interesting and brilliant solutions and see how we can make things as low cost as possible. You raise an excellent point that a lot of these technologies are really expensive. Um, but we have like a really great co-designer who works on trying to figure out how to make creating assistive technology also very affordable. Working with those in other countries and low LMIC countries, low middle income, basically how we can equip them with the tools to also make things like wheelchairs with like very little other than maybe equipping them with the bandsaw, but they might have like other resources around them as well. If you can make things out of bikes, if you can make things out of car parts or something like that. So as a club, we're trying to also see if we can also make these solutions not as expensive because quite frankly, we don't also, but this constraint's a really interesting thing to have. And it keeps us pretty humble. I don't know if you want to add anything.
Yeah, no, I agree. Yeah, we're not like a research lab, so we're not focused on like the cutting edge of one specific hyper specific problem, and kind of just finding an application that fits that like that cutting edge problem. We're trying to really work with the user and make a very user friendly and user centric tech device or tech devices, and that comes with its own set of challenges that are not necessarily as high cost. So cost hasn't really been an issue for us so far. Most of our projects have been under what we've expected, and that also comes from just a lot of the costs from a lot of companies and the high cost of like medical devices is because of the way the industry works and having to go through the whole medical process and also just like as a company having to like pay very high uh like performance people, and we're here volunteering our time, who are everyone here is like really dedicated and very interested in designing these solutions. So it's like a very highly talented pool of people who are willing to dedicate a lot of time and a lot of interest and find really creative solutions.
Okay, I see another question. Uh, does the group accept any ideas from outside? I'm from Mexico and I helped design and code a smart walking stick for the visually impaired with Arduino. Also, I think it's really cool what you do. Thank you.
Um, we um, so we have tried with collaborating with individuals in different countries. The learning like the I guess the communication barrier and the time difference can often be a little bit difficult. But I think we're still open to it, and we're interested in kind of different communities and solving problems for different communities. So one of our wheelchair team right now is working on global solutions, right, Allison?
Mhm, yeah.
So it's definitely yeah, it's not out of the question, although it becomes a more difficult project.
Yeah, I think we also like emphasized this earlier. We really like it when we can like really interact with the co-designers and get to know them. Sometimes like time zone change does make it very difficult to like sync up and actually get everyone on a call at the same time. Because we really think it's important to actually see and understand what's going on. And also if we have like a better understanding of what issue we're trying to solve, like of course the solution is going to be much better and much more personalized to the co-designer. So yeah, hopefully that answered that question. Okay, this is might be the last question if no one else has any more after we answer this one, but I'm hoping to do something similar in high school. Is there any advice you would give for accessing funding since I don't have access to university funding?
That's a good one. If your school has a STEM uh kind of branch or like your science and engineering professor teachers and kind of department, I think it's good to ask your teachers about that and see if they so for like my school we were just starting to build up kind of some kind of a little bit of an engineering curriculum and kind of VEX and FTC, FRC, all of these were starting to come in. And also they were starting in our middle school as well at the same time. So reaching out to the same the school has like a budget for kind of the engineering side of things. So reaching out to admin staff, to teachers to back you up, and then asking the people who started FTC, FRC, and VEX kind of how they started their journey in more engineering clubs in high schools. I think that would help a lot.
Great. Yay. Okay. I think that is like all the questions that have been asked in the chat. Don't know if you have any other final thoughts, Eileen, but otherwise I think we'll probably just like wrap this up.
Yeah. No, I think it's great that people are really excited about engineering and robotics for real purposes. I think that I think a goal for engineers is like to make something that is not just going to sit there and it's going to be really truly useful and benefit a lot of people. And I think that AT is like a really, really great way to do that. So hopefully, if it's not AT, at least you guys will try to find a mission where you can put your engineering to good use.
Yeah. So if you guys come up with a really cool idea during Blueprint, maybe you could even pursue it more, bring it to in college. I know a lot of people who've brought their personal projects into college and expanded on them. You can always, as Eileen said, you can go talk to your teachers to see if they can help you also expand on projects. So possibilities are endless, are quite literally endless, and just take an idea and run with it. And yeah, so I think that will be it. Thank you guys for coming to the talk. We loved sharing a bit about assistive technology and about our club with you guys. And good luck with Blueprint, and we'll see you guys on the weekend.
Do I hop off this call now?
Yeah, okay.